Mark Bare Naked Willie in the house. How are you, brother?
Happy BS Friday live to you, Dave Cooper and friends.
Oh man, what a week! What a week! You're tired. I heard you said, "Man, Dave, I'm tired. I'm burning the rope at both ends." What you got going on that you want to share with the group?
We're cooking up some special batches of 2x8s in the background. I'm just keeping those going in the cauldron. Dave, it's just a phone, right? The phone is on fire. Every time you use it, you got to look for a bucket of ice just to chill it out.
Hey, listen, that's a good thing. We always need the phones ringing, especially if you are in business and you're looking to drive a business forward like T-Stud is doing. So that's cool. Some special 2x8s. And hey, you want to see some of those 2x6s, 2x8s, right? Go back and look at our G-Pod episode that we put up. They're using some out there with Andrew Seeley. So a big shout out to them.
I tell you,
Mark.
every time I think of a Saturday morning, I think of how wonderful it was to pull up and hang out with you, and then how everyone just jumped on the scene from Andrew to me to Jen to Bob and all the other folks. Dave, it was a wonderful Saturday.
Yeah.
Wish we could do that every coffee with Dave.
I know. Wouldn't that be awesome? It was awesome. And it's always fun to hang out with friends. But we do that every Friday right here on Dave Cooper Live, BS Friday with Mark Bare Naked Willie. So we're with our friends. So we're very blessed compared to others who just maybe sit in a cubicle and don't get to see very many people. So with that said, Mark, we are live on LinkedIn, YouTube, Facebook, and
Twitch.
why are we live on Twitch, Mark?
There's an amazing guy out there. His name is Greg Ugaldi. If you don't know him, you do now. So connect with him. He tells us that the generation using Minecraft is the perfect generation to do our digital twins. So be like Greg Ugaldi, jump on Twitch, and bring forth the next generation into our AEC community.
That is right. Bring them in. We have all kinds of digital twins, parametric design, generative design, AR, VR. We are the coolest industry out there, and we're going to keep driving it forward, and we're going to get the youth into this industry. And speaking of Greg Ugaldi, look at the ticker below. This Monday, he is on for his monthly update, and he's bringing Paul Lopez, head of all NAHB communications, the senior vice president of communications and public affairs. You want to talk about somebody that has to get on stage and get the heat every once in a while? I bet that's the guy. So join us Monday, 1 p.m. Eastern. Greg and the NHB has become a big supporter of what we've been talking about on our show. So we're only going to grow if we grow together. So we just want to thank the NAHB and Building Systems Council and, Modular Building Institute and the SBCA and everybody else, SIPs and Panel, Wood and Timber, all of the associations.
Forward Solutions.
Without you. That's it. Hey, listen, Mark, are you going to be out at BCMC this year?
There's lots of mysteries in this universe, but I know who will be there.
This guy. Yep,
Dave
we're going to be there.
Going to be there, and Ben Hershey's going to be there. I tell you, just those two people alone, that's a good reason to go to the show. Just those two folks. You and Ben are amazing individuals, and I'm sure the conference will be great for our industry as well.
It is going to be good because we're looking to bring everybody together. And if you're not familiar with the BCMC conference, you should be. You should come out, check out the T-Studs. Guess where we will be? We will be sitting right inside the SBCA booth doing our live show every day on location. So come by, check us out, say hello, and come out to the show and learn about it. And if you cannot make the show, guess what? We'll be streaming live. You'll get some inside looks, and I'm hopeful Mark and I, if Mark does make it, that we will be on the show together, and everybody else, to include Ben Hershey, should be out there in the one and only Joe Butler and others. So it'll be fun to deal with that. All right. So today, Mark, today is an interesting day. We've kept it simple. We've kept it very simple. The opening dialogue really isn't but a sentence. Today's the day we have a passive ninja coming on the show. And today's the day that we're going to reveal ninja secrets. And the only way you're going to learn about them or hear about them, and this guy's like Superman. He runs races till his legs falls off for fun. Doesn't make sense to me, but he does. But you're going to learn some secrets today from somebody who's very passionate about this, so I'm looking forward to it. What do you think?
I tell you, when you think about construction, it's a method of endurance, right? It's
Right.
training, it's experience. Ian engulfs that in his lifestyle and his experience, certainly in his career and his projects. So, um, we were talking before the show. How do we prepare for this? And you're 100% right, Dave. You don't prepare for the passive ninja. Passive
Nope.
ninja arrives, and he might have already been there, and you don't even know. That's the beauty of the passive ninja.
Yeah, yeah. You think he's gonna come in with a mask on, just the eyes, and his son is like that speed racer dude from the Minions, just a million miles an hour. Yeah, yeah, yeah. Or no, the Incredibles, the Incredibles.
The
All right,
incredible.
all right, let's jump into this, Mark. We got a lot to cover today. We got a lot of people tuning in. The comments are already starting to light up. So looking forward to that. We will get to you, but first, Mark, let's make the introduction. Go ahead.
Yeah. So while we're introducing Ian, a reminder to everyone that's tuning in: tell us what you do in the industry, whether you're from the architecture side, the design side, the engineering side, the construction side, the monitoring, the modeling, the certification, commissioning, the supply, the manufacturing. Let's engage and feel free to chat with your industry pals and new friends during the show. And when you have a question, just put that big Q there. That way, Dave can remember to distinguish that from all the comments, and we'll bring in your question live and we'll have it asked. So, the passive ninja is very well known in our community. So, today, joining us from British Columbia is Ian Robertson, and welcome to the show.
Hey, Mr. Ian Robinson
Hi there.
in the house. How are you, sir?
I'm good. It's a rainy day, but I had a good long trail run yesterday, so that let me get the outdoors without getting wet for the next 24 hours at least.
So you went from a professional rider, I'm assuming like bikes, and now you're a professional runner. You may not call yourself that, but anybody that holds records, in my opinion, in a running sport or any sport, is a professional. So well done. You look healthy.
Thank you. Some long days going long distances.
Yeah.
Yeah. What's your longest run so far?
Longest run was 83 kilometers in a day. So we ran from Vancouver to Squamish via the mountains. So it was also 5,000 meters of climbing.
So it's vertical
break.
as well. And
Wow.
roughly every 10 kilometers is 6.2 miles, give or take. So that's, wow. Six
Yeah,
times 8, that's a 50-mile run.
A bit over 50-mile run, yeah.
Yep.
Nice long day.
I'm tired just thinking about that. Absolutely. Well, that's cool though. Listen, everybody has a passion, and we find people that are successful in what they do. They have passions. They're driven. And that's one of the things that's part of your nature, is to go out there and push yourself and push the envelope and be better at what you do. And from what I'm understanding, the name Passive Ninja did not just come out of being lazy, sitting on your butt and doing nothing. So my guess is we're going to learn a lot from you today, Ian. But first, Ian, we want to know everything about you. From the moment you were born to this very moment in time, do not leave out any of the good stuff from the hospital, or Mark's mother, Diane Willie, Miss Willie, is going to be calling your mother, and we're going to bring her on the show, and we're going to learn everything you don't want us to know. Now, you only have 2 minutes to do it. The floor is yours. Go for it.
Well, my mom might be watching, so who knows? Born in Canada, in Toronto, moved down to the States, lived there for about 15 years, in Nebraska of all places, so very flat, but lots of wind. Did architecture undergrad, then architecture master's down in Australia, because they have beaches, I could live on one, and also I could start 6 months earlier, which is nice. And then, I've been in Vancouver for 10 years now, basically. And because, again, they have mountains, and why not use them? And I've been getting into doing a lot of passive house construction and using a lot of this stuff I have behind me here, just because BC's got so much really cool wood, and why not use it? because it's interesting and there's so many interesting things that you can do with it.
Yeah. You got a whiskey already? You didn't tell us we were bringing whiskey to the party.
Much coffee, that's all.
Yeah.
Oh, perfect. All right, so I know there's some history, Mark. You were saying how Ian's really folded into the passive house community and well known in the passive house community. Clearly, he likes what he does. I mean, here's somebody with wood on his desk behind him, right? And windows and glazings and computers. So why don't we jump into this a little bit? Take us on the journey, Mark. Set us up for what we're going to learn today.
I met Ian last year. Many of us met during the happy hour on the accelerator, and Dave and Jennifer and all of us were on there. I got to meet Ian and have some private roundtable discussions. That moved into emails, LinkedIn connections, phone calls, and just kind of try and keep up with them, really, which is an endeavor. So I always say architects have an incredible amount of experience to get to the part where they are in life. And oftentimes, the background behind them is full of all these incredible books and examples from the industry. And then there's architects that have desks full of different products and different assemblies and different breakdowns that they use. And I've always enjoyed the conversations with Ian when he has these examples and he brings them forward so you could physically kind of wrap your mind around a visual mock-up of what will be happening in the field once the project commences. So beyond that, the skills that I've witnessed from Ian is being able to take you through a set of drawings and the details of the sequencing needed for these elaborate details to commence. And he's really been a force in the industry that I enjoy watching. And so from that, Ian, I think we could start with your desktop and move forward from there. It's a joy. It's a joy to share how your daily and project routine happens, and we'll cultivate that live here today.
I love it. Mark, you need a napkin. You're drooling over this a little bit. Yeah, right there. There it is. Right there. Right. No, you missed it. Right there. All right, Ian, let's go into it. Let's share your desktop and let's walk through some of the things you're working on. Sound like a plan?
Sure. So, there's so many cool things.
You want me to put up the desktop, the share screen?
He's actually showing the. I think, am I right, Ian? You're showing the things on your actual desktop.
I was actually going to show my actual.
Oh yeah, throw those then. Go ahead. Sorry, I'm getting my desktop.
I can do both here. So there's so many cool things. Like you've got this stuff, which is a Koya, which you can dunk it underwater forever and it doesn't care. All of the things that you can't do with wood normally, you now can with this because you don't have to worry really about water protecting it or anything else.
So let me ask you, Ian, is that just a natural? I mean, what's in that wood that allows that to happen? Like, what kind of wood is it? What's the process to get the wood to where it is, or is it just natural? Cut it down, mill it, and hand it out type stuff.
This one is just a type of pine, so it's counts as like bog standard SPF really. And they basically pickle it with a lot of temperature, a lot of heat, and transforms it into something that is basically water agnostic. And they make an MDF version of it too, which is no longer available in North America because it was too popular in Europe, apparently. And on my last project, we actually literally got the last stock in North America, because basically for at least a year or two, there will not be any more of it, which is sort of strange. Really?
On the OSB. Can you hold that up to the screen, the camera, so we can see that?
So it's literally just, looks like OSB, completely indistinguishable from anything else. But it's something then that you can use as an exterior material that you just put a little bit of paint on it and you don't really have to worry about it. So you can shape it, you can do whatever. And it's this nice big panelized product then. And there's not that many panelized products that you really don't have to care about in terms of protecting them too much.
And what about insects, things like that?
Is that
none of them like it. does its thing, and it allows some really interesting flexibility when, for use as cladding, because it's cheap compared to a lot of other things for cladding, for instance. And because it's just wood, you can put it on a building just like a simple wood product. You don't have to use fancy fasteners and cleats and all this kind of other stuff like you do with a lot of other things. So that's the thing that was first at hand, just because it's fun flexibility. This is a nice big chunk of stuff that I like a lot. It's the world's thickest plywood, basically.
Yeah, it is.
And so this is actually, thin. They make it up to like 12 inches thick. So this is some folks in Oregon, Freres. And so Freres brothers, French to English. But it's pretty cool because it does some things that like CLT won't, for instance.
Give us some examples.
Well, I mean, CLT, when you're trying to use it as a CLT, often the layer thicknesses mean that if you're having to deal with it for fire rating, a lot of the bottom meat you can't actually like use in terms of structure, and a lot of the pretty bit at the bottom is actually then not very good structurally. So you end up sort of paying for nice looking wood that isn't actually benefiting you structurally at all. Whereas often like the best looking wood is actually going to be the best structural wood. So it's kind of odd that you're going to have to, essentially burn your nice expensive wood, in a way that you don't actually get benefit for. Whereas this stuff, I mean, you can put pretty things on the face of it, but since it also it's also a lot less costly than CLT is typically. I think it's about 20 or 30% less costly. So you're not so like CLT is an expensive product. You want to feature it. You don't really want to hide it because, again, you don't want to hide your expensive pretty thing. So then you've got this kind of, do I want to feature my expensive pretty thing or do I want to hide it? But if you're featuring it, then you have to protect it all through the construction. You have to make sure that everyone's on board with like, don't screw up the pretty thing, which is hard on a building site when you've got water and you've got everything else. So having a material which you can, you're not worried about hiding, but you can also feature is pretty cool. Like if we go to my desktop, I can you can use it in
the desktop. Got it. I'm with you now, man.
Here, using it for stair treads because why not? Like you can use it as a feature thing as well.
Yeah.
So you can use it in kind of any way you want, and thickness-wise, it's actually a bit more efficient than CLT too because you've got more things going the right directions.
Right.
So, yeah, it's a fun thing that not a whole lot of people are using yet. I have a feeling that we're going to see some more of it, for instance.
So why is it 20 to 30% less? Is it the way it's processed? Is it the type of wood or pine that's being used? Where do those numbers come from?
I think because it can be a bit more automated because you're dealing with big sheets of essentially plywood that you're gluing up together instead of like 1,000 little tiny boards that you have to figure out.
Okay.
CLT, you start having to press it from both sides, otherwise you get cracking. And then a lot of the first CLT projects used wood that wasn't pressed on the sides, and then you had an expensive pretty thing, but that actually had all sorts of cracks. If you looked at your ceiling, you can see all the joints in between them, and you're like, oh, my expensive pretty thing doesn't actually look so good. Oops. And that's just a function of what would have existed in North America. I think if you use European stuff, usually this isn't really a problem anymore. But for instance, yeah.
Well, the technical word we're learning today is expensive pretty thing. But so what you just showed us there from Oregon, essentially, it's kind of like a glue lamb, but it's plywood on steroids, right? So you get you said up to 12 inches, and then I'm assuming. Does that go beyond the 4 foot? Can that be 6 and 8 foot wide as well?
The panel is, I think, up to just shy of 12 feet by like 48 feet. So 12 foot by 48 foot by 1 foot thing can span almost anything.
Wow.
Yeah, when you think about that, that's structural. But then the way we're dealing with buildings today, and the way the Passive Ninja deals with the buildings today, is now that that's one monolithic layer, your air sealing is taken care of. And I mean, I'm a lover of plywood, so I think aesthetically it is also very pleasing. So you have a continuous visual surface, 12 foot by 48 foot. I mean, that's a shotgun in NOLA, right? That's getting your rim and the band on the whole first floor, 48 feet. Yeah, what a simple way
How,
to air seal.
how you lifting that, and how you putting it on in the field, or is this so? I mean, that's a big piece of lumber to move. So I'm sure it's not light to do. But my guess is it's if you can do it, it's helping with shear walls, engineering. You need less wood. You can have more insulation. I mean, there's a whole lot of value to it. And we talk about this in offsite all the time. Why can't we have 12 by 48 sheets of plywood, sheetrock, or anything else if we're using mechanical things to help us put it in place? What's your thoughts on that? Can this be installed in the field, or is this mostly used in commercial applications?
Well, I think if you're using it on a smaller project, you then have to take advantage of the fact that you can put it up quickly. So yes, you have to have a big crane involved, but it only needs to be there for a day. So, it's a cost, but it also then goes, it's not a huge cost.
Yep.
And then you get into also interesting hybrid things where you could use it plus some things to stiffen it. And I think Mark knows maybe something that he might recommend to stiffen it.
2x8s,
it might work pretty well, for instance. Or there are lots of interesting ways that you could do hybrid structures, for instance, where you're using one thing for vertical load, one thing for your big panel object.
Yeah.
It just makes sense. I mean, it's essentially the way that old school like timber frame buildings were done. You had big spaces between the big timber frames, 8, 10, 12 feet. Then you infill them with something else. That's your shear resistance. So you've got your vertical load from these larger members, but they're, discrete. And then you've got your strong object. It has to be strong, has to be stronger than normal sheathing, but it doesn't necessarily need to be so strong as to hold up the entire building with. And I think in terms of also like because wood got a lot more expensive, using it redundantly, I think isn't all that efficient. Like using this big, huge slab of it in a vertical sense is probably going to be overkill. Whereas using discrete columns of it, then connecting by other things is, I think, a lot more sensible way of doing it, honestly.
Yeah, I like that sensible aspect and the versatility it gives. Because right now, the three of us are kind of thinking in the vertical aspect, but that same assembly could be used, as a shed roof or a platform.
Yeah,
And
good.
in terms of moving it, Dave, I went to the same example that Ian did, whether it's residential, commercial, industrial. Our prefab and our modular are already doing that. Our concrete tip ups are already doing that. So, whatever your framework happens to be, from columns to traditional timber framing, all that could be a nice synergy of mixing the materials together. If you're a wood enthusiast, I have to think that you're really enjoying that aesthetic. But in this capacity, you're enjoying the structural, and again, that air sealing of having 12 by 48. Beautiful, beautiful way of making your connections.
And you would probably only use that 12-inch thickness, for instance, if it was a horizontal structure.
Yes.
And then, you're spanning with that, and you're spanning a long distance. And then you might even also then help it out a little bit with, if we go to my computer desktop.
Computer desktop. I love this one.
Yeah.
This is a DLT, actually. So this is Dowel laminated timber. It's in one-way span. So all of the timber is doing work. Unlike CLT, where you do have it going cross directions and some of it's not helping you so much. So it's essentially the slimmest wood assembly you can do to span a given distance. and then you can help it out more. So this is a small piece of steel that's embedded about 1.5 inches into the wood and sticks up about 1.5 inches. And there's a couple of these across the span, so that when you put a couple inches of concrete on top, then the concrete becomes all of your sound deadening, and becomes then also your it turns a bouncy wooden floor into just a bomber concrete wood hybrid structure. And it's a wood concrete composite, it's called.
Wow.
So you're using almost no concrete. I mean, you're using about the concrete that you would normally. For instance, if you had like a in-floor heating, you'd be almost using the same amount of concrete just because you're heating. And this is then turning that into an object which is useful.
So
instead of just sort of redundant.
If that spline, the next picture is good. If that spline is embedded, right, basically dadoed out, and then it's raised 1.5 inches for the same capacity, if you needed to. Obviously, whatever thickness that DLT is has a high resistance layer as it is, but then with 1.5 inches of Gifcrete or StructureCrete, now you could run, if you wanted to, depending on your region, you could run your radiant tubing through that, and now you have this heated mass. Like you said, it's taking care of the joy of the bouncy wood, and now it's giving you that great finished concrete layer, all because of the steel spline interacting.
Yeah, I don't have the photo of this album, but we ran a bunch of electrical conduits in it. We could have actually technically run sprinklers through it as well, as long as the pipe ran this way, parallel to the span. Because parallel to the span, then you don't need that extra. You can have a couple inches that don't have as much structure, basically.
So what is that floor sitting on?
You've got some really interesting flexibility, and also the other way of doing this is putting in about 1,000 different like nails or screws into the surface, dotting it, and then it binds it together. But that takes ages. This is a dude with a saw blade, and an hour. And they can. Is
this just sitting on regular? Is this just sitting on regular floor joists?
No, this is a 2x8 DLT floor spanning 26 feet.
So with that on top, with the metal,
26 feet.
Right.
TGI equivalent would be 16-inch ones at 1 foot spacing, I think. So much thicker, and then you'd still have sound issues. You'd still have other issues, basically. So
that's incredible.
It's interesting how efficient then you can make. So yes, it's got more wood in it, but it's got as little wood in it as you could possibly have to do a span.
And that's 8 inches thick.
Yep.
Well, 2x8, so it's 7.25. Yeah.
So with that being there, its TGI equivalent might in fact be taller, right?
Yeah, it would be 16-inch TGIs to span, nominally 16-inch to span 26 feet.
So
and they'd have to be at a pretty high density as well. So you'd be having to use still, I think 1 foot spacing, I think is what you typically have to do for that. And then you need still a topping on top of that.
Right.
As well. So you'd end up having the best part of 20-inch thick floor. And this was ish 9 inches thick. So, if you put this on a building, you start adding this up. That's the best part of a foot per floor that you're then getting as a bonus, essentially.
What kind of deflection do you get out of this?
Before the concrete was in, it was a bit of a diving board. After the concrete in it passed every jump test you might want to do on it. So very little. They actually, when the concrete was going in, actually put some struts underneath to pre-camber it very slightly. So treating it as if it was, this is a way that you would do a little bit more, like a big concrete bridge, for instance. You do this more. Yeah. But, really not that hard. The shoring had to be there for just a couple days just to let it settle, and then they could take it out. And you could easily do that on it. And it was only like 3 shoring posts versus for a concrete building, you have like 3,000 of them. It's a completely different scale of what you need for this kind of thing.
Right. I can't imagine there's a lot of places that are making this DLT. But if your elevation is critical, which it typically is, this is allotting for that to happen. And you oftentimes have to have a drywall or cementitious layer between your floors anyway,
Right.
for sound and fire safety.
Exactly. And then it ends up getting into multivariable calculus too, because you've got some types of mass timber which are like built into the code, and then some you don't. Some you have to get equivalencies for. Some you have to get a building envelope. I mean, a code consultant to essentially wave a magic wand and sort of like, this is equivalent to this. You can use this. Some places you've got it built into. In BC now, you do have some other mass timber built into the code. And you can do up to 12 stories now in mass timber without having to go through as many hoops as you did even just a couple years ago. But you still only have a certain number of things which are given as a fire rating intrinsically. And this gets interesting. A lot of, like in Canada, for instance, it refers back to studies done in 1942, which is crazy to me. I've got the document open on my screen here. It's crazy to me that we refer back to this document for anything, quite frankly, but it's just baked in forever because you had all sorts of mass timber buildings that were the old warehouses, and the proof that they work is the fact that they're still there. So I think that kind of bakes some of these things in. So that gets into nail laminated timber, which is structurally very similar to DLT, except the nail laminated version is in the code and the DLT isn't. So you can just use, you can give your inspector the code provision for the nail laminated timber that you couldn't for the dowel laminated. So there's more hoops and stuff like that. You have to go through. And then so you've got some people producing NLT now, but not that many. It's surprising that one is kind of like the forgotten child, even though it was the first one.
Yeah.
In a way, Dave, like just looking at this book, right? You wouldn't picture that book and say 1942, right? The cover of that book is really emulating the holy grail for people that are into wooden structures. But if you classify, like Dave is always on the offsite soapbox. If you look in the upper left-hand corner of this photo, right? There you have the crane rigging, right? Just right there.
Yep.
So that's in 1942. We were bringing this in. And then if you go to the photo on the right, it's showing the components, right?
Being installed.
That looks like a panelized construction to me.
Like every bit of it. Like as much as we're chasing endurance for the future, this is actually giving us the backbone of saying we did this in 1942. Now we could do this with incredible tech and deliver it like pizza.
And more knowledge, and literally more knowledge. Listen, I just got done watching, the Hogsworth with my kids. And I have to tell you, I mean, the old books are good books. There's a lot to learn from history, and I'm sure in that book not everything applies, but there is a lot that does apply, and I think that's something to be taught, and for younger generations to be taught as well. All right, what do you got here? Solid wood walls, floors, and roofs. This from the book?
This is the thing that refers back to that book. So this is where it has anything that counts as solid wood. In this case, it's NLT. Or there's two different things that qualify for it. It's NLT qualifies, so you can have a 1 hour thing if you've got a 2x7 thickness. It's odd. The dimensions are a little strange. At 45 minute if you've got a 2x5. And then you can add a layer of gypsum to that to make the 45 minute into a 1 hour rating. So this is something you don't even have to think about. It's just like, will this thing span my thing? 114 millimeter. Oh, it's got an intrinsic fire rating. Oh, sweet, I can use it. You wouldn't have to do any other problem solving than that. And the other version is the splined version, which is the equivalent to the panabode kind of construction. The double tongue and groove. That's the one that I don't actually have a photo for. but also the forgotten child. That it's this. Any mill could make this up. There's hundreds of mills that could be making this stuff up. That could be making a mass timber product. With NLT, you've got a certain nail spacing that you have to do prescriptively, and it's thousands of nails on the thing. With the tongue and groove one, there's no fastening as part of the schedule, so which means you can do whatever you want. Right. Which means all you'd have to do is take a couple of these tongue and groove boards together, attach them in any way that you could actually lift them with, and then there you've got a panelized mass timber product. I'm just going to bring up a photo.
I've visited a number of kind of mid-century modern buildings over my lifetime, and they often have those 3x5s of redwood, tongue and groove redwood, and that is the entire ceiling of the shed roof designs. And then of course they would do some sort of tarring layer over the top, but the inside is that full-on redwood. And I've seen these buildings 50 years later, and it looks like they just finished them yesterday. They're gorgeous.
Like any of these, like the this could be used then as a floor. You get an intrinsic fire rating out of it. You get a super efficient span, because effectively it's the same one-way spanning capabilities as NLT or DLT. All the wood's going the right direction, all the everything. You could then do the hybrid topping on it if you wanted to make it stiffer. Mm-hmm. And yeah, again, 100 mils could do it. Very, not many do. And of course, it becomes maybe you need a custom thickness if you need it to be 5 inches thick or 6 inches thick, right, or something like that. But you can totally get it. And, they're, manhandleable elements as well. Like, a 20-foot version of that, it's still going to be under 100 pounds. So you can still have only a couple guys lifting it, for instance. And then even if you don't want to do a huge panelized thing, you can just chunk them in place as big, big, huge 2x4s, essentially. And then have a mass timber building without all of the difficulty that most, without requiring big cranes, without requiring any of this kind of stuff. So you can take it both directions. You could either panelize everything, or you could go the little bits and pieces route and still get all the benefits, really.
And with this process, in the floors, it's 20 to 30% less than traditional ways that you'd have to do a floor like that or a panel system, or no?
Material or thickness, or 20-30% which? Sorry.
Well, no. So the cost of using this material in a build, where do we look in when you compare cost to traditional methods?
I think the cost of NLT, which is sort of the cheapest of the panelized products, ends up, I don't think it's really that much of a premium, depending on the cost of wood, yes, over traditional stuff, especially if you factor it, if you can take advantage of the speed involved. I think the last time I looked at the costing for, I'm just going to give nominal numbers just to give a relationship between them. NLT was high teens per square foot. The double tongue and groove stuff was like 15, but you'd have a bit more labor.
Yeah.
The mass plywood was low 20s, so like 22. The cheapest CLT was high 20s, and most CLT was in the 30s. So this kind of gives the range. There's about a 2 times multiple between the cheapest possible mass timber and the CLT higher end mass timber. And then you've got some other things like essentially glue lambs. If you try to make a floor out of that ends up being more like $40 per square foot. That's the most expensive option. So you can adjust your costs massively too, depending on what you choose. And so it's a little bit, like I said before, a multivariable thing a little bit. So you have to understand why you're using the thing you're using. And that's why, the CLT is really cool, but there's also things that are maybe more useful if you have a very specific thing that you want to do.
Yeah, some people jump into mass timber because they're aesthetically attracted to it, and then they pick the one that's marketed the most, right? So they just jump into the CLT, and that's the joy of this discussion is, you're voicing the strengths and the capacities of other products that are actually delivering you a more uh, structural structural reach in terms of span, and the fact that that NLT technically could be done on site. I don't know if all projects or craftspeople are willing to take that on.
Yeah.
But you certainly could. I mean, again, being in the code from 1942, that means it was done on site a heck of a lot, right?
Yep.
In especially our large industrialized buildings, they use that routinely, as well
Wow.
as the tongue and groove that you mentioned. Like,
Yeah.
you could visit those buildings again and again, and those buildings have changed uses over time, but that wood is solid as the day is new.
Totally. And yes, you do have to worry about sound going through a solid timber floor quite well, because I mean, we all know what drums do. But this is also then a mitigatable thing. You don't need much on top of it to decouple.
Right.
And you probably want something else on top of it anyway, honestly, to decouple it. Footfall wise and everything else like that, or just even to allow greater flexibility in terms of renovation. So, for your floor surface, if it was a warehouse, you actually might not mind the wood surface. Like, old warehouses actually did have wood floors too. But from a modern, kind of more durable sense, having a couple inches of concrete there is way less concrete than you'd have normally on a building. But then it adds a level of durability and everything like that that's quite useful.
Yeah, and I'm just on the concrete side, sitting on that wood, and you think, like you said, it deflected before, but because that metal, I'm just trying to point this out for everybody, because you put that metal rod through there, or rail, I guess it's kind of U-shaped in, or L-shaped in, or T-shaped into that wood, whatever it is.
It's just steel bar. It's
And
just steel bar.
And it's acting like a rebar when you tie it together, right? That's basically what it's
tying
pulling it together.
It's tying the two together so that you've got these little.
So it's a stiffener plate or a spline, Dave.
Yeah.
Right. So does it have ridges on that bar to catch the concrete, or?
Well, the thing is, it's perpendicular to the span. So the span is that way. You've got the little splines there.
Yep.
So the concrete's on top. You've got the splines that tie the concrete down to the timber.
Right.
These things are perpendicular to the span, so they're not going anywhere. And then you actually cant them in slightly. The outer ones on each side, you cant them.
Got it, to lock it in.
And so it doesn't require anything to bond them, just because it basically is just it's a one-way span. It's going to deflect this way, which means that they're going to tie it in when they're perpendicular.
They can't deflect, right?
Intrinsically. It gets a bit more difficult if you have a two-dimensional span. That's when you would need something going both directions to get it.
Sure.
And that's when, like, NLT doesn't work. If you want to do a two-way span, you do not want to use NLT, because literally then the nails are the only thing that are helping you and everything like that. So you could do a 2-foot span, with it, but you wouldn't want to do a 10-foot span with it, for instance.
Right.
That's when actually, if you load up the photo that I've got here for my desktop, you've got a couple different things happening. You've got a site-built NLT floor, and then this is that 4-inch in double cantilever mass plywood, and that was the thinnest possible floor that we could do. And this is spanning 8 feet from the nearest beam.
Wow.
And then that actually we used without anything on top of it, because the spans were low enough. That floor became then the finished floor as well.
Wow.
So, and again, just as long as you're going to have enough of it to make the truck work effectively, to get you the material. Right. And that was the finished floor of this area, and we used it as a wall as well.
Very cool.
This does get into how you protect it during construction, which is non-trivial, but that's a separate issue.
Yeah. And can I get this in New Jersey, Pennsylvania, or do I have to come to Canada to get it?
Well, the plywood's the Oregon one, and this becomes the thing. It ceases to become cost effective to some extent the longer you ship it. So you don't really want to be shipping mass timber from East Coast to West Coast necessarily. However, the weird thing is because it moves by boat, getting European mass timber is actually often like a lower carbon footprint than getting North American stuff, because it'll come to a lot closer to you on a really efficient object. Sure. And then depending on how far away from the boat you are, then that's most of your carbon footprint. So that's why you can actually get really cost effective, like Austrian CLT, for instance, that often you can get cheaper stuff from there than you can from here. Just because it's also more of a commodity product there too, like they do it all the time.
Right.
Let's hop into a couple comments here and say hello to a few people. You guys good with that? Scrolling up to the top, let's see. We got Damien Stapleton all the way from Dublin, Ireland, joining us today. Damien, thank you for joining us today. We have Mateo. What's up, Mark and Dave? Boxy here. Glad to be tuning in today. Jennifer says Mark is on fire. Well, I hope not. I hope not literally. Right? We got Buzz. Happy Friday from Buzz. What's happening, Buzz? Buzz has got his PS Passive House dictionary available today, which is good. Rob Howard is joining us. Happy Friday. What is happening, Rob? Good to see you as well. Of course, Greg Ugaldi, the immediate past chair of the NAHB. The man, the myth, the legend comes to us from Twitch, and he will also be on our show this upcoming Monday. So you definitely want to join us this Monday with expert Greg Ugaldi and Paul Lopez, who is the Senior Vice President of Communications and Public Affairs. I'll be curious to see if he has as much gray hair or as little hair as I have from all the stress of a job of public affairs in D.C. I could only imagine. So it ought to be a lot of fun to have him on the show. So join us. Good to see you, Greg. We got Ben Larson says, pushing the building envelope. And I know he had another question down below. We'll get to that in a minute. David Martinez, all the way from Chicago, Chi-Town, the Windy City, Mark Willie's backyard. Sean saying, no more's in the house. I really want to run with Ian, but I haven't learned how to fly yet. Ian is your go-to for passive house details, for sure.
We'll all right, Ben Larson. Next time. We'll get Sean a good drone, and then he can come along with me.
We can get him one of those rocket suits, right, where all the rockets come out of your arms and you just kind of zoom around.
He's got a helicopter. Come on.
That's what I was going to say. I just started, right. Where's your helicopter, Sean? I haven't gotten a ride in it yet. All right. Ben Larson asks, isn't it still just a sheet of vapor, impermeable, mostly glue? I think he was talking about the plywood in the beginning of the show when you showed us that exterior that said that it's kind of water resistant or not, water doesn't bother it.
I think that was referencing maybe the medium density fiber board.
Yeah, I think so.
That was probably the MDF. Yeah. Well, I mean, I think the glue content of it is probably a pretty small fraction. It's probably not dissimilar from a piece of plywood, for instance, because of the way it's all squished together.
Right.
I mean, you're not really using it for its structural value. You're using it more for its cladding value. And then you've got something which is mostly wood as a cladding versus fiber cements or metal or anything else like that have, I would bet the carbon calculation for it is better than for most things, for instance.
It's a really interesting question. I don't have the answer, but if we were to take the glue content of Glulam and the glue content of MDF, OSB, plywood, etc., right? These materials that are also prevalent in our sites. It'd be interesting to learn what that content is, because clearly we need that binder for those elements to connect, and that binder has to last for the duration of the product. But I don't have that information, and if there's someone in our audience that is savvy with that percentages, there's a lot of folks that would love to hear from you. So
I would imagine, because I know that they are squished when it's done. So I would imagine it's not more than I would bet it's not more than 10%, and I would actually bet more that it's probably not more than about 5%. But yeah, I don't know.
You know, but if you take a piece of, let's say, 7/16 plywood and a piece of 7/16 OSB and 7/16 MDF, they all weigh considerably different. Like, I'll take the plywood all day, let someone else carry the OSB, and let a whole other person carry the MDF. So there's a density factor with that as well. There is some air in the panelized. So Sean is saying 5%. I'm not sure if that's for all of the above, Sean, the glue lam, the OSB, MDF, and plywood. But that's interesting. And then
I'd also bet that the glue was the most expensive part, so you would want to use the least of it as possible, quite frankly.
Right. And you lose it during the pressing of the wood objects. It flows out the sides. You got to clean it up, right?
Yeah.
It's a deal.
Yeah. And in terms of vapor impermeability, well, you use it in a rain screen, and every single cladding material basically is vapor impermeable. Wood is as soon as you paint it. So there's not a whole lot of people who are cladding their building in fully permeable materials.
Right. That's
especially
totally
in Canada.
Correct.
Yes. Especially not cabins. And
Yeah, for sure. All right, Iwana Mrose. I think I said that right. Greetings from Chicago. What's up with Chicago, Mark? Everybody's joining from Chicago today. Good for you.
I know that BS Friday Live is on a lot of newsletters, Dave, and so it's a reminder for everyone to click their newsletters because there's education out there, and it's everywhere. I love the world we're in today. Teach construction. Amen
Canada.
to that. Canada has some cool solutions. Yeah. And they got great codes too. It's called a step code. Get on that path.
Well, that's a whole nother conversation, the step code. But man, have we covered it on the show. So go back and watch the YouTube channel. And if you're not subscribed, subscribe. And if you're not following Mr. Ninja Runner Biker, overachiever himself, Ian Robertson, you're wrong. You should go follow him as well. And if you're not following Mark Bare Naked Willie on his journey in life and all the things that he's doing to build it better, build it healthier, and be smarter about what we're building, you're wrong. Be following Mark Bare Naked Willie as well as Sean Say No More. He's always on this show as well. He's a big advocate and a lot of fun to have around. And every once in a while, the squirrel gets a nut. He knows some stuff, this guy. I love it. All right, hold on. We got another. Hold on.
Oh, okay, got it.
There you go. Read it out, Mark. It's all you.
So Teach Construction, again, beautiful name, Teach Construction. It says, Mark, in the mock-up behind you, and I'm so happy to see that you have not included the extraneous framing that folks continue to put into the sills. Oh, got it. Not needed and drives me nuts. Hey, so a pirate walks into the bar. Bartender says, you have a steering wheel down your pants? Pirate says, "Arr, it's driving me nuts."
All right, Mark. All right.
Okay. So, in the background, do we have more questions, Dave?
We have just another comment, but go ahead. It's just Teach following up on what they said before.
Okay, beautiful. I'm wondering, Ian, if we could. We went heavy into timber. There's some wicked, awesome things still on your desk. Would you like to speed round? We've got
Sure.
a small window of time. Check this out, Dave.
This one's pretty cool. So it's from Alberta. It's a very thick window.
I'd say.
This thing is like R18. And the cool thing about it too is that it's strong enough because it's so thick. You don't actually have to put it in a frame. So you can actually, like, this is some thermal buck that I've got on here. I'm like, this is kind of a fun little way of putting it in. You use some
Right.
choose your own brand tape to connect the two, and then you suddenly got, how much money do you pay for a window frame on a building? A lot. Versus, this stuff is, I think this one is $35 per square foot.
Which is the same way we do our commercial storefronts, right?
Yep.
And we drop that in.
Yeah.
It's just our residential windows come in that framing package, and then the U value is inclusive of what the glass is doing and the gases and that framework. And then certainly you have this incredible, in some cases, frame, incredible sealed glazing, but then the framing members around the window install don't have the value. So now the U value of your assembly has just collapsed. So
even on the best passive house window, the frame is the crappiest bit by far. The glass is so much better on a passive house window, any of them, than the frame is. So, on a building, a good window is going to be $100 a square foot, say. It's going to have less than half the performance of this stuff, for instance. And yeah, I mean, I think if you're trying to put that in a frame, it's tricky because, of course, who makes a frame for a 4-inch, 5-inch, 6-inch thick window? But if you ignore the whole idea of having a frame on it, then it does get trickier in places where you have to follow NAFs, where you have to have NAF certification on North American Fenestration Standard. But even in places that have NAFs, there's ways of doing, essentially, you usually have to get an architect involved. You have to go through different code provision to be able to do it. But essentially, this then just becomes part of your wall system, more considered than part of your window system. So you don't have to get the same certification necessarily.
Are they operational, or are they just solid fixed windows?
This one, you probably wouldn't want to try to make it operational. So you would then have, your solid windows might be it. And you could butt them next to each other too, which is kind of like, so no frame, just, this to this.
Right.
6 by 12 feet is, I think, the biggest size you can get for it. So you could do an entire window wall of no mullions, no nothing. Have a nice big beam over top of it. Of course, you don't really want deflection touching it.
Right.
But then, you've got a cheap but incredibly high-performing thing, for instance. Like if you the math on having, say, R20 windows, if you're putting that into an R25 wall, which is not much better than code, you got near passive house performance overall, depending on your climate and stuff like that, of course. But because then you don't have the math, you don't have the averaging of your R50 wall getting dumbed down by R7 windows, 6 windows, whatever it may be, or R2 windows. And anytime where you've got a substantial glazing fraction, if you've got 5% windows on your house, well, then it's not going to matter. If you've got 40% of windows, it's going to matter a lot.
Right.
If you've got 50% windows, you can just divide the 2 by 2 and average them out for what the performance is. And 50 plus 8 is not a great average.
The fact that it comes from Alberta, it gives folks in that region a huge advantage, right? Because again, like what you mentioned earlier, is logistics are a factor in costs. But if you're building an R40 wall in Alberta, which I hope you are, right? And you could actually get this glazing system to an R40. Now the people, pets, and refrigerator are causing almost too much heat for that space. It's incredible, that technology. And again, with great technology comes the great responsibility of using it correctly and installing it correctly. So a mock-up to show that new system is there. And like Dave mentioned, what about the operable? Well, then you can have a transom or a tilt and turn so that you can, throw paper airplanes at your neighbors.
Yeah, you would want to then do like a feature, almost like an inset. Now you've got your wood thing, and then you continue your glass or something like that. You treat it as a design element more, as opposed to just. I'm seeing actually that on some commercial entrances now, where you've got just glass, and then you've got this really cool wood door, and then you do just glass again, for instance.
Yeah.
Or you do the way that actually you see sometimes in Europe, where your ventilation element is actually not a window.
All
You've
right.
got a solid thing that does all your ventilation because you're separating the two, which in some ways might be more prudent with this, because matching the color of this to a triple glazed IGU next to it would be a bit tricky. So that actually might be a prudent way of doing it. So separating out the two functions.
If you had a CLT and then you had a thermal buck or an Armatherm around that, now you just go back with a small rip or dadoed furring strip, and that covers up your liquid or tape or caulking mechanism that or backer rod, whatever you're using right there, and now you're done. You're completely done, and the serviceability is also there. We can only hope you don't have to take out an R20 and R40 window down the road, but what a beautiful finish. And
I've got the angle wrong. We're getting a little bit. So this one isn't. I think I would always spec it with low ultra clear glass. This one isn't. So this one gets a little bit darker than I think what I would want. And I think it would end up being another $5 or something per square foot. And then that would get the visibility light, because it's a slightly darker than most triple glaze IGUs would end up being, but not substantially. So, I mean, otherwise you end up having to go to like vacuum glass and all sorts of which is really cool. I've actually got a sample on the other side of the room, but it's also more fragile, because then, you really don't touch it. Whereas this, there's not a whole lot of things you can go wrong to. It doesn't even use fancy gases. So you don't even have something that's going to degrade over time, like most, super fancy Krypton windows. In 10 years, they're not going to be nearly so fancy anymore. And, if your passive house certification, for instance, is reliant on that level of performance, it might not be there anymore. And, good ones will last a long time, but still, what is a long time compared to what the scale of the building is? Would you hope that the things would last actually, 50 years longer? And I know that this stuff has, this company is not that old. The technology has been used for quite a while. I think the windows in the Empire State Building use a similar thing. It's basically layers of film inside that are stretched. And
I think Alpine Windows does something like that.
What's that?
Yeah, Alpine Windows uses a film in some of their triple glazed windows as well. So
exactly, yes.
Perfect. All right, so Brett Little was joining us today, Mark. I don't know if you saw that.
I seem
He said, okay, that is concerning.
I don't know what I was referring to.
Yeah, I'm sure there's a context, but we can ask him next week,
because he's going to be where?
He's going to be live, and this is the second year in a row we got to do the kickoff to the Net Zero Conference by Green Home Institute. So, Brett, thanks for joining us next week.
So now we need a study on window EE loss or U value loss over time. Who knew? And we also got Greg Ugaldi making a couple comments. Mark, looks like he's having a little bit of fun at your expense. Mark looks like Forrest Gump at the end of a 50-mile run with Ian, with the long pirate beard. You know what? That is so true, because I think he had the whole beard growing when he did that run, right? That Forrest Gump thing.
And that's all I have to say about that.
Yeah. All right, well, go get yourself some shrimp.
Yeah.
Ian, go ahead, Mark.
Well, in the corner, while we went to Greg's and Brett's comments, he's got vacuum insulated glazing now exists. Evacuated glazing units. Thank you.
I've got the sample here.
Oh yeah, and here we go. The Ninja has jumped out of the frame, and look at this. He's back.
So that's vacuum glazing, and
let's see the edge of that. Turn it so I can see the edge of that. There you go. Yeah.
So pretty thin. So this is, in fact, it's a triple glazed window, because it uses a pair to make the vacuum layer, and then they've got a space and then a piece of glass otherwise. Mainly that's so that they can do. Then you do safety glass out of it, because then you have your tempered versus your not necessarily tempered for your other stuff. It does have a thermal benefit as well, because if you do put gases in and stuff like that, you get a decent.
Right.
But you can I don't know if you can see the little dots in it just slightly. They're hard to. really hard to see because I think it's focusing
Yeah.
on me.
And what are the dots?
The little dots are the things that, can you see them with a, no, I think not.
It's a little hard.
Yeah, they're little like 30. I'll use your units. Like 64th of an inch, kind of grains of sand almost.
Oh,
Those are the things that separate the two panes of glass, so that
Wow.
they basically don't touch.
Wow.
And because otherwise, a big sheet of glass is just going to kiss in the middle. So these
Right.
things basically just separate it out enough, and it's yet so there's thermal conductivity through them, not much. But they're only, 0.25% or something over the overall surface area, so it doesn't take
Right.
that. So then, yeah, you can get, similar R values for this as this. This, I think you can get up to R30 with this as well. You would end up doing multiple pairs of them together, like this air gap, another pair of vacuum, potentially another air gap, and you can kind of stack them that way as well. You probably
Dave, you
wouldn't.
need to get that on your motorhome so you can have a quiet night with your family when you're parked somewhere.
Yeah, that's right. We'll just wrap
Well,
the
that's
whole
why you
motorhome.
should get some, and that's when vacuum insulation then is also kind of fun. But you are reliant on things that you really do have to protect, because any damage to them destroys all of their, like, a normal window, if you crack it, for a while it's still a window at least. With this,
Yeah.
all of your thermal value goes away, and suddenly then you have an R0 window,
Right.
because stuff like that. Vacuum insulation as well. You've got a similar thing. Do you really protect it when you install it? I think I've got a photo actually. If you want to, here's some vacuum insulation.
Sure.
If you switch to my desktop.
Oh, I love this one.
Yeah. So this is the builder. This is stuck down an individual panel. This is ish R30 per inch effective. Being used to make sure that a roof deck didn't have a step up or a drop down to get the same insulation value and to get the same thicknesses as the floor adjacent to it. But
So it's also
you really
a good
have to be careful how you put it in.
application. I love this photo because it's a good application of that product, because
Yeah.
the way in which it's installed, and then later the way in which that balcony area is used, the odds of something penetrating that are really slim. So it's a great use of a 1-inch R what?
Ish R30 per inch.
Good
Wow.
night.
So this is two
R30
layers of the
inch.
material. And because also it's two layers of it, if one layer did have something damaging it, you've got a redundant layer, which you've still got you've got a pretty impressive layer.
Right.
It's
Right.
on top of something that also has insulation. So you do have a redundant too. If you had one panel, one stack that completely went away, well, you'd still have insulation underneath it. So you've only got like a 2 foot by 2 foot area, for instance, of this roof that might be cold then, in theory. But you've got some tolerance for it. Whereas if you use vacuum glazing on that window, well, then the entire window goes bye bye. So you don't have any fail safeness with some ways of doing it. So
A
I think it's prudent to have some levels of redundancy as many places as you can.
A VIP, right, is what the acronym vacuum insulated panel. Very important. People use it. VIP. Better than most opaque wall assemblies. Indeed, that's a true statement, Ben. Pathetically true. We need to be clear of that. In the essence of time, because we're well over, on your left shoulder, you got something wicked awesome. Yep. Look at that beast. Take it away, Ian.
So this one then is a connection between concrete on that side and, well, steel, timber, fiberglass angle or something like that, with a thermal break in between. So this then is a way that you can do hybrid assemblies, because you quite often, you do need some concrete in most buildings. You go to foundation, which is concrete. How do you attach things to it in a way that then isn't transferring through? And if it's a wood building, then maybe you don't care too much because the wood is itself low value. But there are instances where you still want to, you still need to break it more than even just the wood, for instance. And I mean, you can get products that do that same function that don't have the thermal break, but This is available easily anywhere in North America. Shuck is around, and so a lot of towers are starting to use. I mean, basically, balconies and towers now have to use something like this. And whether it's two concrete things being thermally broken, or concrete inslide to something outside, or whatever it might be. But you can use these in like any orientation, so you can use it to help you make connections that would otherwise be either structurally or thermally tricky. So
yeah. So Ian, what do you do on a day-to-day basis? I mean, you have all these gadgets on your desk. Let us know what your day-to-day actually looks like here. And then we're gonna wrap her up.
Recently, I've been working on a slightly crazy house up in Whistler, and
slightly. Did you just say slightly?
Yeah. Well, if you want to go to my screen,
Dave, this is a bridge that happens to be a home,
a house,
right?
Yeah.
It's a cantilever dream.
So it's most houses would build up a huge amount of dirt underneath them to place the house at a certain level, which has, a pretty high footprint. So we're kind of like, well, can you do it something differently? Make the house not hit the ground so much, not have to truck in a couple hundred tons worth of rock and concrete and everything like that. And then, now we don't really have any just dumb dirt that we're putting in the house. It's only a little bit of cut, a little bit of fill. It's about even cut and fill actually for what the basement would require.
Right.
So it's basically, is it as ecologically sensitive as doing nothing? No. It's a big building, but it's a different way of doing a big building in a way that I think has less of a footprint than most might. So that's been my day-to-day,
really
recently
cool.
At least.
Dave, do you notice that this floating top floor, if you will, one, aesthetically, this is attractive. Two, because you're the passive ninja, we know that it's also going to be comfortable for your clients. But in that last screen, as you orientate it over, Dave, there's a pool.
I saw it
up there, because if you're in Whistler, right, the joy of this build is in fact the environment around you, right? Your connection to that. And so it seems like a wonderful client that really wants to take in the outside all the time when they're in the space. That's brilliant, Ian.
So I mean, you've got a pretty huge slope on the site. So effectively the building creates the flat ground that the site doesn't have. And you can see, the corner of the house is about 50 feet above grade.
Right.
Like that's if you try to fill that in, which most houses would do, like it's nuts trying to do that as well. So it's weird, sometimes crazy things are actually the better idea.
So what did you just? And I know we're short on time, but I'm curious. Your beams or your posts or your platform, however you want to call it, what are you using to actually get that structural support underneath? Is it steel and concrete? What is it?
In this case, it would be a steel table.
Okay.
I was wanting to use timber, but even my favorite timber engineers were being like, no, can't really do that. So this is going to be basically using bridge technology, using essentially two beams, one spanning on each side, and then just doing the light infill in between. So basically making a big table can be like a lightweight mass timber or anything else structures above it. The only thing in Whistler, your roof effectively structurally has 4 feet of water on it structurally. So the snow loads that they have there are so great that you effectively, putting a swimming pool on a building isn't actually that hard because structurally it has to have one anyway.
Got it. And then tell me, because that's all open underneath, right? You get all that air movement, that 20 degree below zero winters that come by. What do you use to insulate underneath and around this house to keep it?
Well, in this case, it would just be basically insulating on top of the steel, and then treating it as just a big single story house, effectively, insulating that as if that were ground. And
Yeah. Now I got more questions. Sorry, Mark. We're going to be here for a minute. The what about the core on this? I'm assuming you ran all your mechanicals through a core.
Yeah.
Yep.
And then
And did you?
so it would all be transferring over. You could use the legs to some extent a little bit, but
Yep.
pretty much everything coming back to the core. The core is the thing doing the main lateral work, and then the columns at the end are doing kind of not much lateral, mostly just point load.
Got it.
So because of course we're in a sizing zone as well, so you have to take that into account. So
is that an elevator shaft in the middle as well,
Yeah.
or okay? That's
It
what I
is as
thought.
well. So it's basically it would be a single concrete tube going up,
Yep.
handling the lateral and the lateral service elevator, everything else kind of like. So effectively, it's a tower mentality more than anything else in terms from that.
So
standpoint.
it's three enclosed. So it's 3 enclosed floors with 1 open platform underneath it, in between the second and third floor.
Exactly. Yeah. So that's the idea.
That's really cool. So you could party rain or shine in this house, man. I love that. That's cool.
Well, that's the intention, because like you do have so much snow. Like, what do you have as actually useful outdoor space in the winter?
Right.
You don't really have much. So either you create your own, that we've done, or you have to then spend huge amounts. Like, people spend money ice melting sidewalks in places like this. The amount of energy involved in doing that is nuts, because you're heating the great outdoors. Like everything that your father tells you not to do. You're doing it.
You're born in a barn.
Yeah. So so there's ways of, crazy things sometimes are it's a crazy thing managed in as sensible a way as possible, I think, while still being kind of crazy.
I love it.
Yeah.
Ian, thanks so much for spending your afternoon with us today. I mean, this is cool stuff. The wood's super cool, and then to see a project like that you're working on. I mean, how cool is that you get to wake up and have that as your headache every day? That's a good headache to have, I bet.
That's pretty cool stuff. Yeah, it's a good one.
Yeah, for sure. I would imagine so. Mark, so we have the Brett Little coming up on BS Friday. The one, the only. Is he going to have his rose-colored glasses on, do you think?
I think he's going to have a green topic to deliver on net zero. I can't say what kind of glasses he'll be wearing, but Brett's a good friend of the show, good friend of yours and mine. I'm so happy for today, so happy for tomorrow. Some coffee, Ian. That was a great way to wrap up the show. As Dave prompted, give us a glimpse of your routine during the day, and to be able to show a project like that you're working on. I love challenges. That's quite a challenge, but it has a beautiful aesthetic. And as you said, it's a table, it's a bridge, and it's a part of our nature and aesthetic. So thanks for sharing your skills, the products you use, and I find you very inspirational. Much respect.
Always good to chat.
Yeah. Perfect. All right, Ian, thank you so much. Mark, thank you for joining us today. Be sure to tune in tomorrow, Coffee with Dave. We will go over last week and what's coming up this upcoming week, and just sit around and do a little bit of BS, and not the building science BS, the other BS for a little bit. And then join us Monday, as we will have on the one, the only Greg Ugaldi joining us. And as always, Greg is bringing some special guests, and this week it's going to be Paul Lopez, head of NHB Communications. You don't want to miss this one. It'll be interesting to hear what Paul has to say. And of course, Greg will always come with his updates, not only probably from Capitol Hill, but what's happening around the world and what's happening in our country when it comes to workforce development and lumber prices, and what they're doing to help bring those down and protect our rights as builders. All right, Mark, Ian, thank you so much. I hope both of you have a wonderful weekend. Ian, don't go anywhere. We'll come right back to you after the outro. And everybody else out there, hit that like and share button one last time. And if you really want to support us, please subscribe to our YouTube channel. We'll see you next time. Bye now.